Hello everyone, in this video let us deal with the octal numbers. So we have already dealt with the binary numbers. We have seen how we are going to count in binary numbers. We have seen the addition, multiplication, division, subtraction of the binary numbers. So similarly, we have to perform all these operations, okay, that is with the octal numbers. So you already know that the base for octal numbers that will be equal to 8. Right, this is the base. And what are the numbers that are allowed in this base 8? That is 0 to r minus 1. So r minus 1 will be the maximum value, right? 0 to r minus 1. So now you can see that is 0 to 8 minus 1. So 0 to 8 minus 1 means 0 to 7, right? 0 to 7. That means if you see a number like 2, 3, 4, 5, 8, so obviously this is not an octal number. Why? Because this is consisting a digit which is 8. So any number, okay, to be an octal number, it should contain the digits less than 8. So it can be 2, 3, 4, 5, 7. This is an octal number, but 2, 3, 4, 5, 8 is not an octal number because it consists 8. We have also seen the counting of the octal numbers, right? Sorry, binary numbers. So 0, 1, since only 2 are allowed in the base 2, that is 0 and 1. So next what I will do, I will reset it to 0, and this is the column, this is another column, this was 0, value was 0. Now in this next one I will be incrementing this value, so it becomes 1. So I will keep this as it is, and now I have to increment this. So we have to repeat this process for this, okay, for this if I consider it is like LSB, okay. So to understand, make you understand, I'm telling you that it is LSB. So now what happens, once again I will reset it to 0, and this one will be, okay, incremented, so it will become 1, 0. Okay, incremented means it becomes this one, or else you can also consider it can be next digit, it will be 0, and this previous column it will be now incremented by 1. So you will be getting 1, 0, 0 after 1, 1. So 0, 1, 1 is nothing but 1, 1. 1, 1 can also be written as 0, 1, 1, right? Because I can add a 0 behind this because it is not going to alter your value. So similarly, you are going to count in the octal system also. Octal number system you are going to count. How? You are going to have 0, 1, 2, 3, 4, 5, 6, 7. After 7, what happens? This will be reset to 0, and this column, it will be incremented. The 0 to 1. Again, this one will be incremented 1, 2, 3 till 7. So 17 is the value here. After it reaches 7, once again this is reset to 0, and this column it is incremented. Now I am incrementing here also. Why? Because I can have the digits till 7. So I will increment this till I am getting 7, 7. After 7, 7, what will be the number in the octal system? In this case, this is reset to 0. This is also reset to 0, and this column, now it is incremented. So now this becomes 1, 0, 0. So this procedure goes on till it is 7, 7, 7, right? So this is the counting in the octal number system. So now let us see how to convert the octal number system to binary system, binary to octal system. Okay, so suppose this one you can consider. See, this is my decimal numbers 1, 2, 3, 4, 5, 6, 7, 8, 0. In binary, what I can write? This is 0, this is 1. So now for 2, what happens? This is reset. This is 1, 0, this is 1, 1. This is 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 0, 1, 2, 3, 4, 5, 6. This is 1, 1, 1 for 7. And again 1, 0, 0, 0 for 8. So this is in binary. This is in binary. So now in octal, what you will write? It is 0, it is 1, it is 2, 3, 4, 5, 6, 7. And for this 8, now it becomes 1, 0. So you can say that in octal you have 0 to 1, and here in binary you can see from 0 to 1, 1, 1. Now I can replace everything with 3 bits, right? 0, 0. If I'm adding here 0, it is not making any difference. So this is all 3 bit, right? So till 7, it is 3 bit, right? It is 3 bit. So this is the actually octal one. This is the binary one. So for this octal values, what is the equivalent binary digits? It will be 3 bit representation in binary. So that's why we can say that to convert an octal number to a binary number, okay, what you have to do is you have to convert it into binary, and then that is you have to make the group of 3 bits, like 3 bits if you are going to consider, then you can convert it to the octal one. Okay, 3 bits, it will be equivalent to 1 octal digit. 0, 0, 0, it is 0. 0, 1, 0, it is 2. So this binary, it is equivalent to this in the octal system. Okay, so likewise, what happens if I have binary, okay, this is converting binary to octal. So suppose I have 25 octal, convert this to binary. How you are going to do? See, for 2, what is the value? 0, 1, 0. Write this as it is. For 5, what is the value? It is 1, 0, 1. So 1, 0, 1. So this is the equivalent binary representation for the corresponding octal number. Okay, so 25, 8 is converted to binary in this case, and here I was converting binary to the octal. So now we understood, right, why we are grouping 3 binary bits, because this is the reason. Till 7 you are having this 3 bit representation of the binary. Okay, so now we will see the octal addition. Suppose you have 23 and 55. You have to add this in the octal. 1, 2, 2, 3. So what is this? This in octal? 2 plus 3, it is 5. 1 plus 2, it is 3. So this is in octal, obviously. Because if this is in octal, if I want to convert it to binary, how are you going to convert, or not binary, I will convert it into decimal. So how you are going to convert the octal into decimal? You know how to convert binary to decimal, right? Because we have already studied this. So converting this binary to the decimal, it involved multiplying with the weights. So it is 2 to the power 0 into 2 to the power 1 into 2 to the power 2 into 2 to the power 3. So likewise, we are going to follow the same procedure in the octal. So I am going to multiply with the weights. So this will be 0, this will be 1. So this is 8, this is 2, this is 10. So this I am going to cut 10. This is in decimal. So how are you going to convert 23? So 2 into 8 plus 3. So 16 plus 3, it is 19. So in decimal, it should be 29. Okay, now we will verify whether this is right. This is in octal, this is in decimal. So now how will you convert decimal to octal? So to convert decimal to binary, you already know you were continuously dividing it by 2. So here we have to continuously divide by 8. So 29, 8. 8 3 is a 24, then you have 5. What is this? 35 in octal. Here also we got 35. So this is 35. In this procedure, you are going to follow this method. That is bottom to top approach you are going to follow. When you are converting decimal to octal or decimal to binary or the decimal to hexadecimal. Okay, so this is the bottom to top approach. Okay, then this is the addition of the octal numbers. Okay, so one thing is you can directly convert, you can directly add it, or else you can convert the octal number to the decimal number and then again convert the decimal back to octal number. So it is time consuming. So better practice this in the direct way, like how to add with the base 8. Okay, so now let us see this. 3 plus 5 is 8. Okay, what I will do, I will write it. 2 plus 5 is 7. So is this right? Is this right? This is not right. Why? Because I have already told you that the octal should not have any digit equal to the base, that is 8 or greater than 8. So 8, 9 is not allowed in the octal system. Okay, that is allowed in the decimal, but it is not allowed in the octal. So this is wrong. So now how are you going to write such problems now? How are you going to solve? 23, 35. So you have to add this now. So now let us take 99 and I will take 99. You know the answer for this. What is the answer for this? This is 100, 100, 200, 200 minus 2, 198. So the answer will be 198. So how did you get this? First you went for this column. You added 9 plus 9, 18. 18. But I didn't write 18 here. I wrote only 8. Then where did this 1 go? It went here as a carry. It went here as a carry. How are you going to say that? So 18 can be written as 10 into 1 plus 8. Right? 10 into 1 plus 8. So this came here. So 9 plus 1, 10. 10 plus 9, 19. So now I took this. The remaining I took as a carry. So this carry came here. Similarly, we are going to do it for the octal system also. 3 plus 5 is 8. But how are you going to represent 8? It is 1 0, right? 1 0. So what I can write? 8. How can I write 8? Sorry. How can I write 8? So similarly, okay, this is the decimal system. Here I took base. This is base. So here also I will take base 8. To get 8, I can multiply with 1. And what can be this? It can be 0. So this one I took here, right? So similarly, now what I will do? I will take this here. What I will do? I will take this as a carry. So 3 plus 2, 5, 5 plus 1, 6. So this is my octal. So how will you verify it? How will you verify it? 23 in decimal system. 2 into 8, 16 plus 3, 19. And what about this? 3 8 is 24, 24 plus 5, 29. So 9, 9, 18, it is 48. So convert this into octal. So 8, 6 are 48, 0. So this is 60. So is this matching? So I follow two methods. One is directly using the octal system. Another one is converting octal number to the decimal number and then again converting decimal to the octal number. So these are the two procedures that we can follow. Okay. Or else we can do something like this. I can convert that 010, 011. I can convert this 011, 101. I can convert it to binary. So this is 110, 0, 0, 0, 11. So again what I can do? I can write this. So what is 110? It is 6. 0, 0, 0 is 0. Okay. So previously this one also I can do this. 0, 0, 1, 0, 1, 0. How is 2 represented? 0, 1, 0. How is 3 represented? 0, 1, 1. So now add this. What is 0, 1, 1? It is 3. What is 1, 0, 1? It is 5. So this is converting to binary and then back to octal. Okay. So this is also an easy method that you can follow. So next we will see. Likewise, you can take multiple problems and you can try to solve. Okay. Just remember this technique, how actually you are solving in the decimal system, and the same thing you have to apply in the octal system. So next you can go for the subtraction, right? You can go for the subtraction. Like 29 minus 8. It is in the decimal, so it will be 21. Okay. What is the technique that we are using? We will see that also. 9 minus 8 is 1. Then you get this here. So if I take octal, 23 minus 11. This is the octal system. 3 minus 1 is 2, 2 minus 1 is 1. This is in octal. Directly I can subtract it like decimal. Okay, so now I can convert this to decimal. So how are you going to convert the decimal? You are going to multiply the weights. So 2 into 8 is 16, 16 plus 3 is 19. 1 into 8 is 8, 8 plus 1 is 9. So this is 10. So can I convert this to octal? 8 ones are 8. So this is 12 in octal. So the same thing I have obtained here directly. This is converting to decimal. Okay, so this is an easy one. How we are going to subtract it. But suppose now I have 23 minus 15. What happens in this particular case? What happens? Suppose this is my decimal number. This is in the base 10. Okay, this is in the base 10. So how are you going to subtract this? 23 and 15. You should get 8. You should get 8. But how are you going to get that 8? What I did, I took a borrow from this. Since it is giving a borrow, this is subtracted by 1. So that becomes 1. So now this is getting a carry 1. Okay, this is getting a borrow 1 now. So this is nothing but taking a borrow of 1 is nothing but you're going to add 10, that is the base, with this particular digit. 10 plus 3. So this now it becomes 13. 13 minus 5, it gives you 8. So that it gave you 8. 1 minus 1, it gives you 0. So this is the actual method that is going to be followed. So here, if I go to the octal system, here also this is giving you carry of 1 and this is subtracted by 1. This is giving you carry of 1, that means it is giving you 8. So you have to add this with the particular digit. So that is 8 plus 3, that is equal to 11. So if you are subtracting 11 minus 5, what are you going to get? 6. Is this the answer? Is this the answer? Okay, let us check if it is right or not. So 2, 8, 16 plus 3, 19. This is 8 plus 5, 13. 19 minus 13 is 6. If I am going to convert this into octal also, this will be 6. So did I get the result now? Did I get the result? Yes, I got the result. So likewise, we will take another problem. Okay, so we will take 51 minus 27. This is in the octal system. So first let us convert to decimal. 5 into 8, 40, 41. 2 8 is 16, 16 plus 7, 23. So subtract this 23 and 41. What are you going to get? You're going to get 18, right? You're going to get 18. So if I'm converting this to octal, 8 to the 16, 22. You should get 22 in octal for this result now. So we will check it. So this is 1, 7. So obviously I can't subtract a higher number from a smaller number. So what I will do? Minus 1 I will do. I'm getting 4. And I will be giving 1 carry to this. So 1 carry means it is equal to 8. So I will be adding it with the digit. This digit. It becomes 9. So 9 minus 7, that becomes 2. So 2. 4 minus 2, it becomes 2. So did you get the technique with that you're going to follow here? So you are getting a borrow means you are going to get a number which is equivalent to the base number. In decimal it is equal to 10, in octal it will be equal to 8, in hexadecimal it will be equal to 16. Okay, so similarly if you are going to do the multiplication also, like if you have something like 23 into 35, okay, you can do this also. 3 5s are, you have to convert this in, okay, octal. So make sure you are not going to write 3 5s are 15 and this will be wrong. This will be wrong because you are performing this in the decimal system. So if you want to convert, if you are comfortable with the decimal number system, go for the conversion first. Convert both the numbers to the decimal, get the answer in decimal, convert that back to the octal. Okay, or else you have to perform this with the octal system only. How this 15 is represented in octal, you have to check that. How is 15 represented in octal? You have, right, 0, 1, 2, 3, 4, 5, 6, 7. After that you have 8, 9, 10, 11, 12, 13, 14, 15. So till this you had 7. After this you have 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. So what happens? 7, right? And 1 it goes as a carry. 5 to the 10, 10 plus 1, 11. How are you going to represent? It is 13. So 137. So this is 137 here. Next 3 3s are 9. How are you going to represent 9? It is 11. 1 carry. 3 to the 6, 7. So this is 7, this is 4, this is 8. Sorry, 7 plus 1, 8. But 8, I cannot write it as 8. I can write it as 0, 1. 1047. So let us check this. First let us convert it to octal. So I will use my calcium and then I will just verify. 2 8s are 16, 16 plus 3, 19. And here 3 8s are 24, 24 plus 5 is 29. So you are going to get 551. So if I am converting this 551, okay, this one, 8 8s are 64, 64, right? So 64 means your 8 9 8 6 are 48, sorry, 8 6 are 48, you can hide 6 7, right? So 8 6 are 48, 48 7, so you have 71. So 8 9 it's not possible, 8 8s are 64, 8 8s are 64, so 64 7. Okay, so next comes 8 8 8s are 64. Okay, this is 4. Next what happens? 8 and 1 and 0, so 1047. So is this right? Yes, you have got the answer 1047. I'm going to divide this and I'm going to get back it in the octal system. But we saw the direct multiplication using the octal also. So 3 5s are 15. No, it is wrong. It is going to the decimal system. You have to see what is equivalent in this. So you can convert this, right? 8 1s are 8. 8 7 15. So this is the octal representation. Or else you can directly go for the conversion. And similarly, this goes for the division also. Like you are going to do the multiplication, you can try for the division. Okay, so this is the simple method. So we have also seen the conversion of binary to octal. We also have seen conversion of octal to binary. So this is all about the octal system.